Hello everyone, it's Miss Johnson here, and I'm here to give you our first video in Unit 9, Unit 9 Notes 1 on inverse variation. Our lesson objective for today is I can write and graph inverse variation equations. If you look at the first example, it says the number of revolutions of the pedals made when riding a bicycle at a constant speed varies inversely as the gear ratio of the bicycle. In other words, as the gear ratio decreases, the revolutions per minute, or RPM, increases. This is why shifting to a lower gear allows you to pedal with less difficulty when riding up a hill. So as the gear decreases, the revolutions per minute increase. That's why it's inverse variation. Inverse variation, y varies inversely as x if there is some non-zero constant k such that x times y is equal to k. So this is the standard equation that we're looking for. We're going to be writing and graphing this equation today. We have x times y, that's multiplication there. X times y is equal to k. What this means is as one value goes up, the other value goes down. That's why it's called inverse. Let's take a look at number 1. It says the time t takes to travel a certain distance varies inversely as the rate at which you travel. The equation r times t equals 250 can be used to represent a person driving 250 miles. Complete the table and draw a graph of the relation. So here's our k value. Okay. And we need to use that k value, or use that equation, RT is equal to 250, to complete the table. So I'm going to take my R values and I'm going to plug them in for R. So I'm going to start with 5. I have 5 times t is equal to 250, and if I solve for t, I get t is equal to 50. I can keep going and do that for 10. 10 times t is equal to 250. Solve for t again, divide by 10, and I get t is equal to 25. I want you to pause the video at this time and see if you can fill in the rest of those table values. Okay, so I've completed my table here. I have all of the t values, and I'm going to go ahead and graph those on my coordinate plane. So treating these as coordinates, if this is my x and that's my y, when x is 5, y is 50. So here's 5 and up to 50, right about there. At 10, I'm at 25. 15, 16 and 2/3, about there. 20 is 12 and a half, right about there. 25 is 10. 30 is about 8 1/3. 35, 7.14, 40, 6.25, 45, 5.56, and 50 is 5. So you can see we get kind of a curve here. It comes down from way up there and keeps going and curves like that. So that's the graph of how long it's going to take depending on the rate at which we travel. Now it makes sense. When we're driving, if we drive at a faster speed or a faster rate, then it takes us less time to get someplace. That's why it's an inverse variation, because as the rate increases, the time decreases. So we get this going down effect. Okay. Let's take a look at number 2. It says graph the inverse variation equation in which y varies inversely as x when y is equal to 15 and x is equal to 6. So here's our steps for getting this taken care of. I first need to write my equation. Okay, so the first thing I'm going to do is I'm going to write the equation that I need. I know that when x is 6 and y is 15, that's going to be my k value. I have to find that k. Okay, so I already have the 6 and the 15. I can put them together to give me the k. That means I have a k value of 90. So if I take that and write an equation, that means when I have x multiplied by y, I'm going to get a value of 90. That's the equation I'm going to use. Okay, now in order to fill out our table, notice that there's no x values chosen there, so we have to pick them. So the second step we're going to do is we're going to pick some x values. And I'm going to choose my x values strategically. I'm going to pick x values that are divisible by 90. because when I do that, I'm going to get some nice numbers. Okay, or in other words, divisible by my k. So the x values that I'm going to choose are -9, -6, -3, -2, and then 0, and then I'll just go back up, 2, 3, 6, and 9. So all those values are divisible by 90, which is going to give me some nice numbers. So that's the third thing that I do. The third thing that I do is I find the y values. So I can use my equation xy equals 90, and I can plug in the x's that I've chosen. For the first one, I have -9 times y is equal to 90. When I divide by -9, I get y is equal to -10. So that's my y value. Then for -6, I'd have -6 times y is equal to 90. Divide by -6, and I get y is equal to -15. So I can keep going and find all these values. -3 times y equals 90. That's going to be a y value of -30. -2 times y equals 90. That's going to be a y value of -45. Now take a look at what happens when we have 0. If I had 0, I have 0 times y is equal to 90. Now here I would divide by 0, but we can't divide by 0. That's not allowed. And if you try to type that into your calculator, you're going to get some sort of error. So this y value is actually undefined here. And we'll talk about what that looks like on the graph. And then I just turn and go back down. So I've got 45 here, I've got 30, then 15, then 10. So let's go ahead and label our graph. That's going to be the last thing that we'll do. My fourth step, I should say. Fourth, I'm going to label the axes and graph. So if I look at my x and y values, my x values are going up to 9. So I'm just going to say maybe I should count by 10, or count by 2's to get all the way up to 10. So this is going to be 2, 4, 6, 8, and 10. That's -2, -4, -6, -8, -10. And then my y values, I need to get all the way up to 45. So I'm going to count by 10's for my y's. That's going to be 10, 20, 30, 40, 50. That's -10, -20, -30, -40, and -50. And then let's graph these points. So I want you to pause the video at this time and see if you can plot those points on the coordinate plane. Okay, so here I've plotted my points in green on my coordinate plane. And now I take a look at the two different pieces. I kind of have two pieces going on there. Here's the one piece, and it curves like that down in quadrant 3. And here's the other piece curving up here in quadrant 1. Now, the reason this is split up into two pieces is because of this. At 0, at an x value of 0, our value is undefined, meaning that this is never going to be touched. Okay, so that's why our graph kind of gets split into two pieces, because we're never going to actually touch the y-axis. All right, I want you to pause your video and see if you can work on question number 3. Write the equation, follow the steps that I laid out for you, and see if you can graph it. And let's move on to number 4. In number 4, it says the owner of Superfast Computer Company has calculated the time, t, in hours that it takes to build a particular model of computer. It varies inversely with the number of people working on the computer. So that makes sense. More people working on the computer, the time it takes is going to go down. The equation P times T equals 12 can be used to represent the people building a computer. Complete the table and draw a graph of the relation. So the table that we have there, they've picked some p-values for us, and we are going to go ahead and find those. We also have an equation. We have p times t equals 12. So let's go ahead and find those t values. I have 2 times t is equal to 12, which means t equals 6. Then I have 4 times t is equal to 12, which means t is equal to 3. And then I have 6 times t is equal to 12, which means I have t is equal to 2. And I'm going to leave the rest of this example for you to finish. I want you to finish filling in this table and see if you can graph the equation. Thanks for watching your video today, and we will come back together tomorrow. Have a great night.